welcome to this talk about optimizing the VM or helping users optimize and maximize the VM performance. So about me, I'm Polednik, and I work as software engineer at Red Hat. Now, maybe the interesting part is that I'm not directly working on KVM or QEMU or oVirt, but what I'm working on is a management solution called oVirt on top of oVirt. So this is actually kind of high-level talk that should serve as a bridge between two groups of people. On one side, there are users that want these nice, clicky web UIs. And on the other hand, there's KVM, QEMU oVirt, that we're trying to get best performance from. Wow. So what it boils down to looks like this slider. And I was told that this slider looks really bad because you don't know, which side is actually getting better. So if you don't like it, just imagine scale in its place. The main thing is, on one side, you have a flexibility. So in terms of VMs, flexible VMs means you have the ability to migrate the VM. You can run it on one of the hosts in your cluster, or you can connect to them graphically via SPICE or VNC. On the other side, you have performance. Now I'm talking raw performance, networking throughput, storage bandwidth, or just the generic compute performance. So you see when you start moving the slider to either direction, what happens is that you either reduce flexibility or you reduce the performance. Now that's in theory. In practice, what actually happens is if you try to improve performance, there's a high probability of you just reducing the flexibility while not getting any performance improvement. And because that happens quite often, I was thinking of a way to analyze it. And one of the ways seems to be some kind of data analysis. So this is kind of rare because talking of oVirt, it's an on-premise solution. So you don't normally have any kind of runtime data that you could analyze on. It's not kind of cloud that you just tap into database and see what happens. But you really have to go and grab the data from somewhere. In this case, it was SOS report databases. That's the great thing about our SOS report, that it actually contains the whole database. And putting this all together led to quite a big data set. So you can see there's like 40K VM definitions, 700 clusters, over 2,000 hosts. By the way, I'll be using host instead of hypervisor, but I mean the same thing. And around 60K disks. Before we go on, I've used the term cluster that probably deserves some kind of definition because it's kind of foreign concept to KVM. So what it means, let's consider cluster as some kind of migration domain and scheduling domain. So it's VMs, hosts they run on, their disks, networks, everything together. Since we'll be talking about clusters and actually machine types, we should establish some kind of relationship between the two. And there's a great timeline that you can see how machine type and cluster version is related. It begins, in this case, with oVirt 3.6, where the cluster version used was RHEL 650 cluster version. Then we go on and see 4.0, which maps to 7.2 cluster version. And the current newest release is 4.1, which maps to cluster version RHEL 7.3. Now, there are cluster versions before 3.6, and there will be cluster versions above 4.1. It's just that in this case, the databases weren't really from that point of time. So it's important to remember that this is really some limited data set that's not like all of the history. First, let's look at the machine types. And this is pretty interesting. On the chart, you can see that the most used machine type is not actually RHEL 7.3, which would be the newest one. It's actually RHEL 7.2, which is one version behind. And there's actually a reason for that, and that is the cluster update. It's not a trivial process. It requires some kind of extra resources, because how that works, if you want to update a host in the cluster, you first have to grab the VMs from the host, move them somewhere else in the cluster, and then only then you can update the host. So there are some resource requirements. Another reason why people are running older clusters is that there are simply no new and interesting features that they could use. So why move on? So now let's transition to the actual VM configurations, and let's see what the dataset revealed. And we'll start at one of the most important tunables, which is NUMA. Now, NUMA is interesting because it's not, we are not using it only for the performance benefit itself, but there's also a certain class of applications, like those huge databases and ERP systems, that scan the NUMA and try to optimize themselves within the guest. So if we don't expose NUMA topology that somehow matches the host, the application will simply do a bad thing, so there will be no performance improvement. It's actually going to be worse. Also, some context how NUMA is set up. It's important to know that in oVirt, it's all manual. We don't really help the user, create this kind of node and this kind of node. No, it's just select number of nodes, select which nodes those pin to. So there's kind of no holding hand. You're left on your own. And thanks to this, we have discovered two issues. The first one is what I call soft NUMA violation. And it's what you can see on the slide. Soft NUMA violation happens when there's a NUMA node, and if host contains a NUMA node that's actually smaller than the NUMA node that VM requests. And in this example, it's just single node VM, so it's pretty obvious that it doesn't fit into the smaller of host nodes. This can actually be solved by pinning the node to the bigger node, or actually removing the host altogether from the cluster. And we have seen this happen in roughly 17% of definitions. Now, important thing is that those are not all VMs in the clusters and all VMs in the database and all hosts in the database. This is really looking at the cluster itself. So this is actual happening scenario, nothing theoretical. The number is pretty high, but as it happens only in the worst case of cluster scheduling and host scheduling, we don't really believe that this is too significant. On the other hand, we have a hard NUMA violation, and that is when the VM's NUMA node simply exceeds all of the NUMA nodes on the host. So it's not possible to simply fit the VM onto the host without somehow splitting the node in two, for example. Now, this has been seen in roughly 9.74% of definitions. And again, not theoretical cases. These are practical, actually happening cases. Unlike with the soft NUMA violation, you can't really solve this by pinning the node because it doesn't fit anywhere. So this is worst case in cluster scheduling only. And that means it's quite significant issue that we should do something about. And there's a possible solution. So as you can see based on this presentation, we have the data required to see whether this can happen in the cluster, it can't happen in the cluster. We can warn the user. We could probably even make something more intelligent, but let's say right now the software doesn't really want to take the responsibility and do that on user's behalf. So our safe ground in this case is some kind of warning dialog. Maybe in the future, as confidence in this code increases and there are no user issues, then we can do that automatically. Now, the pinning was mentioned multiple times, but it turns out people don't pin their VMs at all. Why is that? Now, again, this is case of not exactly user-friendly approach. We don't give a hints on how should you pin your VMs, where should they be pinned, and that they should be pinned at all. So this is not really used at all. Even worse than NUMA pinning itself is the CPU pinning, where we have even custom syntax that we have to figure out how to use. And again, there's no information about that. Additionally, some management level constraints arise from pinning. So no migration is, the migration is disabled at management level. You're also reducing the amount of hosts that you can run on by some kind of pinning. And in that case, you're hitting an issue with high availability. So just in short, high availability is you trying to have a VM that has maximum possible uptime. And if the VM dies, you restart it elsewhere. That's kind of conflicting with the previous point, because now the places, the hosts where the VM can be started are only a subset of the previous version. So we may hit problem with HA. The question is, can we change that? And it turns out there are approaches to do that. So first is, of course, obviously lifting the management limitations. But then the pinning could be done in some kind of algorithmic way. So we have this example here of pretty beefy host with 4 NUMA nodes and 12 CPUs per NUMA node. And in that case, we have kind of borrowed an idea from real-time KVM, where you reserve a portion of the CPUs in each NUMA node for some kind of service tasks. So we do have some kind of daemon, libvirt can run there, and there's emulation threads and IO threads. So these can run, in this example, on the first 2 CPUs of the NUMA node, where you leave the other 10 CPUs, or sorry, cores, as actual vCPUs for VMs to use. If the number of vCPUs is actually bigger than you can actually fit into the node, again, we're asking the user, oh, well, this may not be optimal, create another vnode. And since really this is taken from real-time ideas, in case we want to adopt real-time KVM, you already have some kind of good starter, because we would just have to think about isol CPUs and no AZ full for the compute CPUs. So that's pretty nice benefit. Now, one thing to remember is, in this case, what you want to do is still let the user configure the number of service CPUs, because in case of, a host with only 4 CPUs per NUMA node, you don't want to steal half of your compute capability just for services. Now, before we leave the topic of CPU, there's one more tunable. Now, this is really simple for us, because as you can see, in QEMU, it's just L3 cache equals on. In libvirt, it's just sub-element cache level n, some kind of mode. This is extremely simple thing to do from management level. And in case of L3 cache, it has turned out as something you really want to use in case you have huge VMs. That is because in case of machines with multiple physical sockets, at least the author or the commit message tried some kind of SAP test suite and came to a conclusion that there's roughly 15% on average increase in CPU performance. So this is almost no work for us, and the actual benefit may be huge. Let's get into maybe more interesting areas, and extremely significant improvement that we can make is using Hugepages. So from high-level perspective, what we want to do is, instead of using the standard RAM, anonymous backed memory, we're actually allocating some kind of file-backed Hugepages that, let's say, should improve the performance in some way. They're actually required by some applications, like if you're using NFV with DPDK, you're actually required to use Hugepages. Out of that, I do not have exact benchmarks, so it's worth benchmarking whether they really help or not. Also, if you're only talking about one platform, it's pretty simple, because on x86-64, the Hugepages happen to come in 2 sizes. First is, now I don't want to be wrong, it should be 2 megabytes. The second size is 1 gigabyte, but there's a caveat that some CPUs, older ones, I believe the newer ones support it, some of them have 1 gigabyte Hugepages that, let's say, should bring more improvement in performance. Of course, there's a small difficulty about Hugepages, and that's two kinds of allocation policies. So the first policy is using pre-allocated Hugepages, and that's pretty simple. What you do is specify just Hugepages and their size on kernel command line, and when the system boots up, the Hugepages are there, and there are no issues. The problem with this approach is, of course, if you want to run more VMs than you initially allocated Hugepages for, sorry, you're out of luck. The host doesn't have more Hugepages to accommodate the VM. So there's a second approach, dynamic allocation. That one is done pretty easily through sysfs, where you simply echo the number of Hugepages that you require. Now, it almost seems a better choice than pre-allocated Hugepages. It turns out that allocating, let's say, higher number of Hugepages of big size can take ages. And even after the ages, there's a probability of that failing if memory is too fragmented. So we have figured out that although the benefit of dynamically allocated Hugepages would be huge, for now, let's keep the disabled and just deal with standard pre-allocated pages. So this is one of the cases with this hard resource limit. If you run out of the Hugepages, no more VMs can be started that require Hugepages. That means no overcommitment. This is the hit on flexibility that people expect from virtualization, that you can overcommit, you can run multiple VMs with more total memory than your host actually has. Well, in case of Hugepages, you can't. And we have just defeated, let's say, advantage of virtualization. Another thing are the management constraints. There's no hot plug, hot unplug, no migration. The case of migration is kind of questionable. I've been warned that using 1 gig Hugepages has pretty low convergence rate. On the other hand, that may change, and we may figure out that the convergence can actually happen, and again start lifting these management restrictions. Let's move to some more interesting tweaks, because what we had previously were what we call low-level tweaks. They usually have some kind of flexibility versus performance trade-offs, but in case of VM devices, we're actually seeing maybe even changes in usage patterns. There are some maybe UI changes if some device is disabled or enabled. So this really changes the way you may use your VM management software. The first device you'll start it is pretty mild in this case. It's pretty much invisible until you need it. So it's a pretty simple device as far as I understand. It's what it does is it takes entropy from the host and makes it available within the guest. And this turns out to be extremely valuable, because if you're installing OS, there's probably some kind of PRNG operation. If you're generating GPGKs, there's some kind of PRNG operation. And the same thing is installing some kind of software. This is often free IPA kind of software where the installation took ages. So we had users coming saying, this installs like for 2 hours, while on bare metal it's almost instant. And it turns out that just enabling VirtIO RNG solved all their problems, which is great. Happy user, happy developer. So previously, this was optional. There was a checkbox to enable it. In the end, we have figured out there are probably no downsides, so why don't we enable that by default? And here are just some results of the change. So you can see that in 3.6 and 4.0 versions, it wasn't really used. We are talking less than 4% of VMs. In 4.1, we can see quite a big jump. This jump is still pretty small in terms of total number of VMs, and that is because such default change only affects new VMs. So these are VMs created in 4.1 cluster version, not VMs that were created in 4.0 and then just upgraded to 4.1. And I've just tried some kind of benchmark to show the improvement it actually delivers. Turns out RNG test kind of proved the point, although it's artificial and the actual use case isn't really the benchmark. It's really installing software where many more pieces take place. You can see, actually the blue line was roughly 4 seconds, while the green line was 80 seconds. Pretty good improvement. Now, moving on, we have network. And it turns out network is pretty boring, because I was interested in what could we do on the network level to either improve performance, flexibility, or just find better choice for the people. Turns out the choice we would want people to make, they've already made it. Almost everyone is using VirtIO. The minority is using emulated NIC, which is probably just for compatibility purposes. On the other hand, we have SRIOV, meant for really networking intensive applications such as NAV. These are used, but the expected percentage of VMs that use SRIOV is so low that it's not really even reflected in the data. But it's there, and that's actually what we wanted. So I'd say the distribution is great in this case. So networking is not a problem. Disks, on the other hand, are a whole different kind of beast. So there's a lot of choice. You can see roughly 4 choices. Those are ones offered to the users. And unfortunately, they have quite a lot of choices, but not a lot of information regarding which one should you pick. On top of that, depending on which one you have, which one you pick, there's some kind of difference, not only in how you treat the VM from management perspective, but you even have to start thinking inside the guest. So if I use VirtIO SCSI, I will need different driver than VirtIO block, and maybe my OS doesn't have driver for one. That's a problem. On top of that, the VirtIO SCSI controller pretty much has to be even in VMs that do not need, by default, VirtIO SCSI. And that is, again, a flexibility choice that we did. In case you have VirtIO block only VM and you want to hot plug VirtIO SCSI disks later, you would have to shut it down, so that's not really a hot plug. Adding the controller at least solves that. So it was like this for a long time until trim came along. And it turns out everyone wants trim. It's probably the most requested feature in case of storage. So everyone is coming in trim, trim, trim. That actually was the deciding factor in changing the default, which was previously VirtIO block. In 4.1, we have moved over to VirtIO SCSI. That being said, it's not like we're deprecating VirtIO block. It's still considered more of the performing choice if you have some case of workloads that are really disk intensive, you're supposed to pick VirtIO block. At least we now have a warning about that, but we can't do that pick for you. And the distribution, again, like we can see the change people are adopting, and people are actually happy. So this is the biggest benchmark that's available in case of this kind of data. If people are happy, your mailing lists are not spammed, and people don't have issues, you can't really benchmark it because everyone has different kind of workloads. There are databases, there are big systems, there are test VMs. It's all mixed together. On the other hand, we can see the distribution changing in favor of VirtIO SCSI, while people are happy with that. quite interesting point about this data is that there's still IDE, and we don't really expect IDE to die. There are still CD-ROMs in IDE, which, although may not be ideal, at least from perspective of performance, it's definitely compatible with like everything there is. Maybe even more interesting topic than disks itself are I/O threads. Because it turns out almost no one, although this is dangerous in this room, but almost no one understands I/O threads in higher level software, let's say. So this is a case of shifting responsibility from one layer to the other layer. So we have QEMU that allows you to specify, I think, between 1 and 16 I/O threads, or even whatever number. Then there is oVirt that, guess what, allows you to specify whatever number. So we thought that it would be a great idea to ask the user to specify number between 1 and 16, right? I think it was limited by 16, but I'm not sure about that. Anyway, there was just this checkbox where you were supposed to enter arbitrary number, and that was it. No help, no nothing. Yeah, turns out some people got it right, at least in terms of what we found out. On the other hand, like the 3, 10, 16, those are pretty interesting numbers. I would love to hear background how people chose them. So at least the experience and tips we got, the information, has reduced the choice to one I/O thread. So I don't want to say that one I/O thread is ideal in every case. That would be bad, I guess. But we don't, in the UI, so in an easy to configure way, we don't allow people to configure arbitrary numbers. On the other hand, since there are definitely workloads where this can make sense, this has to be overrideable. So this was a trip of flexibility devices. You know, you had Virtue RNG as first device, where your flexibility didn't take hit, it improved the performance. You had networking, where it would be similar case. Then we had disks, where you start having to choose between some kind of features and some kind of performance benefit. Now there's the biggest issue, and it's host devices. That's using real hardware. That means GPUs, NICs, NVMe disks. This is the recommended choice if you really want to push performance of one aspect to the maximum. On the other hand, for us as the management layer, it brings various issues. So as with Hugepages, this is different limit. If you have a single VM on your host that requires GPU, and you only have one GPU, then you're out of luck if you start another VM. On top of that, there's a NUMA locality. So I've drawn this picture myself, by the way, of a host with 2 NUMA nodes and some, let's say, 4 GPUs that may or may not be physically 4 GPUs. And each GPU is connected to one of the NUMA nodes. And this gets kind of complicated because not only you have to think of in which NUMA node the VM should run, you also have to consider that it should run in the NUMA node where your devices are. Now, this is not that bad if all your devices are from single NUMA node, but I believe, and it was even mentioned in the previous talk, if you have devices from multiple nodes and you have VMs spanning multiple nodes, you have to figure out how to pin it. So, you know, your VM may have 4 NUMA nodes because your VMs are split between, your devices are split between 4 NUMA nodes. It gets really complicated. And this is something that I would love to solve automatically at some point. The problem is this by itself requires us to create the NUMA nodes, and that was our save limit. We are not doing that. We are only warning the user. So this gets really complicated, and unfortunately, it's not solved yet. If you have this kind of setup, you pretty much have to tune it manually. One positive thing about host devices is that there are more and more devices with some kind of virtualization capability. So you have NICs with SRIOV, you have GPUs with vGPU or GVTG, or you may hopefully soon have storage with NPIV. That's really a case that's helping, at least in the sense that you can use device for more VMs than just a single one. Now there are some other devices that it makes sense for management software to include. So imagine graphics, video, you want that for SPICE or VNC. Sound card, you just want sound card. USBs, then there's smart card, Watchdog, and Balloon. These are devices that we really include by default because there's maybe someone who needs smart card in their VMs, and instead of making that explicit choice, it's just better that if you start the VM, you just find, oh yeah, it has a smart card. Unfortunately, when we start thinking of performance, sometimes there are conflicting choices, or it's questionable whether some of the devices are needed. In some cases, we have no idea whether there's some performance hit, benefit, so consider removal of some, maybe reducing the surface or where performance bottlenecks can be. And unless it hurts the use case, removing them should be quite simple. Unfortunately, we really don't have performance data, and if someone was working on that, I'm really interested to see that. Maybe one trick, we've talked about removing video and graphics devices. Well, if you do that, you have just lost your graphical connection to the VM, which is not exactly practical. Normally what you do is use console. This is getting more complicated if your data center is in some kind of subnet that's not accessible. So for that, you need some kind of proxy. So this is all doable. It's just one complication on top of another that's making the use of your software less convenient. So in the end, how we implemented all this? Well, in 3 tiers of changes. There are some of the safe changes. So making VirtIO RNG the default, or if we have host devices in a single NUMA node, then we just make sure that's the preferred NUMA node for the VM. We've actually used the mode preferred, not strict, again, to relax the responsibility that we have. On the other hand, there are some kind of warnings. So if you're creating a VM that you expect to perform on the top level, or some kind of high performance VM, then you should probably use the Hugepages. Or in case you are violating, or there is chance of you violating the NUMA, again, this is the warning, like, oh, make sure this is working. Maybe in future, and that would be beautiful, would be really warning about possible use case of host devices, seeing, maybe inspecting the workload of the VM and telling, oh, yeah, this VM is running this and this, it may make sense to use SRIOV. And then there are a few changes in default. So it was the VirtIO block to VirtIO SCSI transition, or the IO threads change that I'm really interested in seeing the data in the future. So this is, don't try to read it. It's just an example how that could look. This is the case of Hugepages. So if you don't have Hugepages and you have high performance VMs, this tells you, oh, you may be doing something wrong. You're not wrong all the time, but make sure you know what you're doing in this case. It's supposed to be annoying, I guess. Some benchmarks. And this is kind of a letdown in a sense that benchmarks that would probably show the benefit the most are these that you actually have to hire expert to run. So you have this kind of SAP benchmarks and other proprietary benchmarks. These improvements are mainly aimed at those kind of applications, and these are the ones that we can't really test. So I've tried some synthetic benchmarks that were supposed to be sanity tests. So the first one is actually the one that may take advantage of the changes. It's pgbench, so it's from it's running Postgres benchmark. It was like 100,000 transactions, and this was pretty much the result. So there was performance improvement of 10%, which was pretty nice. On the other hand, encoding flag shouldn't really be different on this kind of configuration. So there was roughly 0.1% improvement, which is more of a statistical error. On the other hand, the results will be visible in the next year, maybe in the next 2 years, as people start creating VMs with this kind of configuration and actually report their experience. That's the most important point. So the summary kind of goes in the spirit of, for the users, whatever automation does for you in this area, you still have to benchmark and tune your workload accordingly, because there's no magic guessing. This is almost like if you wanted maximum performance, we would have to take a silver ball and just let it guess the configuration. So make sure to benchmark the workload and see how the changes affect it and keep going in this sense. And the second line is aimed at KVM developers, that there are some ways that you can help us making these decisions, and things like good commit messages. That was the case with else recache, where the commit message explained what it does. There were some benchmarks. It was just pretty easy to adopt. Of course, that depends on you. Like, I'm not saying that everything is wrong. It's just that sometimes it's really hard to figure out whether something should be used or should not be used. And that's it from me. So if you have any questions or, yeah, go ahead.
So my remark, does it work? Yes. So my remark is about the host devices. I think you made a good point that it's really the most important part of getting high performance devices. And I think I have two remarks on that. One remark is that having a host device doesn't actually require using PCI pass-through for that device. Even if it's an NVMe device, for example, you could still be using VirtuoBlock to expose it, but still have the pinning. So having something in the UI that says pinning this disk to this physical disk is probably more important than actually doing SRIOV of that disk. Because having the local storage is what really matters. And at that point, if it's a VirtuoBlock device, for example, you could put the IO thread on the same NUMA node as the physical hardware as well. So in that case, the answer of one IO thread per VM is the best one. But in addition to that, you might have one per NUMA node if there are pinned devices from other NUMA nodes. And likewise, for example, if it's in the future, we are going to have, for example, the NVMe device driver directly in QEMU, possibly. Then you could still expose it as a VirtuoBlock device, but use the NVMe driver in QEMU. So my suggestion regarding the UI is to decouple the pinning from the pass-through. And the pinning is just a requirement for the pass-through. You can still use VirtuoBlock and VirtuoSCSI or whatever you want, even if you choose to pin. And the same for SCSI pass-through. You can have a SCSI device that it's that one, it's a direct pass-through, but still want it for VirtuoBlock for a little bit more of performance, for example. So this would be my suggestion.
Yeah, I believe you have kind of skipped a year ahead, because this is kind of in the making, but it's at the thought level. So that said, like, your thoughts are extremely valuable, and you could actually help us build that. That would be awesome. But yeah, this was all in the thinking. Unfortunately, like something like that we couldn't make just yet, because this itself was a lot of work. Even if it doesn't look like that, like creating the UIs and everything is apparently complex. So yeah, thank you.
I would like to put attention to two topics. First topic is Hugepages and KSM interaction. Once KSM starts to merge pages, your Hugepages will become dissolved, and you will find the performance a bit degraded. So if we are going to the system near overcommit, we will have a difficult choice: start KSM or not start KSM.
Yeah.
But we still want to get a best performance in the conditions we have.
Yeah, we currently disabled the KSM. That was the choice that I forgot to mention.
And the second question is about IO mode you will have over your virtual disk. Do you have any statistics whether you use Linux native backend or threaded backend, cached or uncached mode, because this has a big impact?
Yeah, I actually don't have the statistics like for this presentation. I did some kind of research for a blog post that you could find under my handle. But yeah, there isn't enough testing from my point of view in this regard. And it's also, well, the main reason why we would need to benchmark this. And this is usually based on shared storage. Right.
So sorry, we are out of the time. So if you have any question, you can discuss it with Martin directly.
Okay, thank you.